Everybody. Myself is Prachi and I'm working at the Physical Research Laboratory, Ahmedabad. So today I welcome you all on behalf of the IIST Alumni Organization, IIST Alumni Association for this webinar on the role of academia in the space systems development. And this is one of the events organized as part of the celebrations of the IST Foundation Day, September 14, which is also the commencement day for IST Alumni Association. So I would request all of you to take a note that this webinar is live streaming on Facebook. And now I would like to request Prakhar Agarwal, the president of the IST Alumni Association, to take this event forward. Over to you, Prakhar Bhaiya.
Thank you, Prachi. A very good morning to all of you present here and good evening to Mr. Amal. I'm really happy to extend a warm welcome to all the esteemed panelists and our director of IIST, all the professors and deans from IIST, alumni of IIST, and special welcome to all the other audience joining us for today's session. The life of this session and this participation is very much welcome over here. So I am really happy to extend a very warm welcome to each one of you present here. We're fortunate to have Dr. Dadwal, Director IIST, amongst us here today. He's been instrumental in leading the development of various payloads at IIST and realization of payloads for different platforms. Some of them are under development. So I'll not take much time and I'll jump to invite him for delivering the welcome address. Dr. Dadwal, over to you.
Good morning. So, dear Executive Committee and members of IIST Alumni Association, so Prakhar, Prachi, and the invited speakers for this session, guests, participants, members of the IIST family, including faculty colleagues, good morning to all of you. Except for Amal, I believe, good evening. So it gives me great pleasure to initiate a series of activities that will mark the completion of 13 years of a very eventful journey of IIST and the celebration of the 14th Foundation Day. So educational institutions are known more for the successes achieved by their alumni in comparison to the academic excellence of current students. So with passing out of the 2016 BTech last month, IIST has already now reached the milestone of graduating 10 batches of BTech. So the first batch graduated in 2011. So it is in fitness of things that we start these set of events led by an alumni program. So this will be followed by a program for school students called Passage to IIST, a quiz hosted by alumni for late Ankesh Mishra, a past student, and on 14th, we will have a IIST Space Industry Meet, the 6th Dr. APJ Kalam lecture to be delivered by Dr. K. Kasturi Rangan, and the events will again close on 14th by again a program for IIST alumni. I would like to profusely thank the invited speakers on behalf of the Institute, the participants, and my own personal behalf. Namely, Dr. Amal Chandran is a great friend and collaborator for InspireSat program, Professor Aguiletti from University of Auckland, my colleague Dr. Umesh, and Ms. Rachna, who currently is at Berlin Space and who has agreed to moderate this discussion. IIST as a young institution has taken some baby steps in the space system development. The first hardware designed, fabricated, and qualified by the faculty and researchers of IIST went in space on April 1, 2019 on PS4 platform on the PSLV C-45 flight. Dr. Umesh, who was the leader of the team, I'm sure would cover this along with the other exciting developments. The hardware designed by IIST and launched was Vyom, a sounding rocket, similar to the initiation of the program in ISRO. The sounding rocket, which happened in many years ago in 2012, but it did not reach the altitude to classify as a space journey. So there are many in store, including CubeSats, sensors for ISRO, Mars, and Venus missions, and a couple of other programs. The space systems are challenging. The challenges multiply when you bring them to academia. Even if we discount the major issues of budget and facility and long gestation period, it requires entirely new learning and multitasking by students, researchers, and faculty. The faculty has to also live with the turnover of students. However, I firmly believe they are all worth the effort, and for advancement and spreading of space technology, also developing the future generation of space technologists, the academia must undertake the space missions. I thank Alumni for organizing this event. I am a very interested student in the discussions what will follow. Hope this will be very productive, and this will also lead to development of new collaborations. Thank you very much.
Thank you, sir. Thank you, sir, for all the support, so for inaugurating today's session. For today's session, we have Rachana Reddy, who's from the class of 2012 of IIST, as moderator. She's been a common name and she's well known amongst the alumni community and currently is working with Berlin Space Technology in Germany. She's got a wide experience on her background, and I would now like request Rachna to take over the proceedings of today's session. Rachna, over to you.
Thank you, Prakhar. So, hello everyone. Well, first I'd like to give a short introduction about all our three panelists. So firstly, Dr. Umesh Kadane. He's currently the Associate Professor and Head of the Department of Physics at IIST. He has a background in physics, experimental as well as theoretical atomic and molecular physics. And he has wide research experience in India as well as France and Denmark. And then we have Dr. Amal Chandran. He is currently the Assistant Professor and Director of the Satellite Research Center at NTU Singapore. And he is an aerospace engineer with research background in atmospheric science. So that was quite interesting. I didn't know engineers also could do some research. Well, and he's also a lot into instrumentation for small satellite platforms and also atmospheric modeling. And then I'd like to welcome Professor Aguiletti. So he leads the Space Institute at University of Auckland. And he has quite an interesting profile as well. He has a multidisciplinary background from aerospace engineering to academic research, as well as he's also consulted a lot for the UK industry, the space industry. And he worked on the Columbus module of ISS, the space shuttle program. He was with ESA, ESTEC, Nordwijk, the SARI Space Center, and a lot of many things. So I've just given a very short profile outlines of three panelists. So participants, I'd highly recommend you to go to Google all these people. They're quite famous and popular on Google. They've got really incredible journeys. And since we just have 1 hour and I don't want to keep everyone, and there have been a lot of online meetings because of this corona. So let's directly just dive into the subject matter at hand. My first question is, Amal, it's to you, because you're from Singapore, and Singapore, unlike India or New Zealand, has no space agency. However, most of the space activity in Singapore is being done by universities like NTU, NUS, and a bunch of companies, few startups. So what, from your perspective, how did you take steps at NTU or in general in an academic setting to formulate or to have a sustainable space program?
Start off with. So Singapore's first satellite was built at NTU. And that was the 100 kilogram XSat. It was not quite a CubeSat, it was a 100 kilogram satellite. So XSat launched in 2011 and it's still operational. It's an imaging satellite. The camera is not working, but we still hear some beacons from it occasionally. So it's not quite dead in the water yet. But as you said, right, it does not have a space agency. It's quite a boon, and that sometimes it's a pain because there is no coordinated direction of space or where we are going next, which means, there's a set of uncoordinated activities happening, but we'll get to that. That's a whole different discussion. But you're right, when they wanted to have a space program, they wanted to incubate it in one of the universities. And I was not part of the Singapore space program at that time. That was a little before I joined Singapore. I joined Singapore in 2017. It was mostly a tech demonstrator that, it was an aspiring country wanting to do a space satellite mission. And they had a bunch of engineers with background in engineering, many aspects of engineering. They brought them together and invested in developing a satellite center at NTU. And that's how that project came to be. Of course, they worked quite a bit with external partners. The imager was built mostly out of Korea, but most of the satellite was built in-house. After they built the satellite, what happened was that is typical with Singapore. They commercialized the team. So NTU and Singapore Technologies then spun off that team to ST Satcom Systems, which is now building the Telio series of satellites in Singapore. So as a university, we had to then rebuild. We had to recruit new people. So our next satellite was a 1U CubeSat. So, we took in students, we took in engineers, and then rebuilt that capability of, that knowledge capability, while the facilities were already built up. So we have excellent test facilities, and it's always been, and we'll get into that later on in the program, in the panel discussion, I hope as well. Continuity and knowledge retention has always been a problem. But for an aspiring country like Singapore, for when they got started in space, it made sense to do it in a university. And then, you spun it off into ST, and, people from there have then started spinning off startups. We continue to have a cohort of students that get trained in programs and in our programs, and they start, programs, and now it's becoming a hub for space. But the problem of not having an agency is different. We don't have a coordinated space program, unlike Australia, which just recently started, and you can already see where, the direction they're taking, where, they have a strategic vision of what they want to happen next, which is lacking in Singapore.
It's interesting, but yeah, I will follow up with a lot of questions to you later.
Sure.
I was just getting everyone warmed up, so I will dive into the next question. This is to Professor Aguiletti. You have come from both sides. You've also worked with the Space Center, and now you're with the university. So, what do you think are the pain points for space agencies while working with the academia?
Well, first of all, let me thank you for the invitation and for the very kind words that you mentioned before. Well, as you said, yes, I have always been lucky enough to stay with the fit, in both camps. Although mostly my career developed, in academia, I've always spent a lot of time in industry as well. And so I'm lucky enough that I can see, both point of view when we also deal with the agency. And often, there are a bit different priorities between, universities and companies. Company mainly, they want to, reduce the risk. They want to develop missions not because they want to have, necessarily profitable missions, but for them, there are some imperatives that at the end of the day, they have a balance sheet, whereas university, often they are a bit, more relaxed and willing to take, if you want, more risks because they want to push forward, the state of the art and so on. And so often there is a bit of divergence between, companies that are, you could say, risk adverse, and universities that instead they want to push, research elements and so on, and therefore they are more willing to take again these risks. However, again, the secret is really for the two different types of organizations to really work together, because we are absolutely complementary. For example, one of the main functions that I've always done, in the university is clearly the educational functions. And clearly all the students that we prepare are very useful then for companies, to grow their future workforce. At the same time, the kind of research that we are doing eventually develops into applications and products that there are, taken forward, by companies that they make, commercial success out of that. And so the tricky thing for an agency is really to try to deal with these, different strengths that the various organizations have, and try to organize, for example, programs where both can work together, again, in a complementary fashion, in order to really exploit the synergy that there is between the different type of organization. And again, it depends a bit on the kind of agencies that you have, because some space agencies are a bit more, hands-on in their dealing with companies and with universities. Some other agencies are a bit more, you could say, hands-off. They are just, they create a proper environment for companies to grow and so on, but they are not really, for example, putting a lot of money there to try to steer, projects and programs in a direction or another. They are more, if you want, letting companies in university take their own initiatives, and they just create, for example, a regulatory environment that facilitates, the interaction, or facilitate, the creation of programs and so on. So there are very different, let's say, way to go about it. But the important thing is for the three partners, let's say, like, the government and the space agency, companies on one side and universities, to work together, because again, we play different roles, but when we all play our roles, again, the whole thing is very complementary, and the whole system works, very well, and allows really, great missions to be done.
It's very interesting, but yeah, I will also follow up many more questions for you. So, Umesh, I have the next difficult question, perhaps, is to you. ISRO has the AstroSat and Aditya missions primarily going on in terms of physics or, research or experimental kind of things related to your area. And moreover, the ISRO's mandate is primarily space applications for the community, and also a lot of capacity building in terms of human spaceflight, right now, or the cryogenic engine, and so on and so forth. So given this approach, so how do you make a case for ISRO to focus more on research-oriented payloads or research-oriented missions?
Yeah, thanks a lot to our IIST Alumni Association arranging this program. Thanks, Rachna. It's a very interesting point, actually. There are three aspects of any space program. These are akin to brain, muscles, and heart. So you require a lot of electronics, a lot of avionics to have the brain to go where you want to go. You need a lot of muscles, launch vehicles, engines, and designs. But at the end, when you finish all this, the obvious question comes, where is the heart? And that is where a government and a space agency usually takes a decision. When it comes to communication services or remote sensing services, or whatever can actually earn revenue for the government or support revenue making for any government agency, government would like to support that, whether it comes from private industry or it comes from government agency. Like in India, it's mostly comes from the government agency, but I'm sure that's also going to change soon. Finally, the question comes that would somebody develop a very powerful rocket or a very powerful avionics just for a particular commercial mission? Usually not. As Professor Aguiletti also pointed out, that when it goes to commercial applications, the purpose has to be served rather than the technology developed. So as I often quote to my students, science can develop in vacuum of requirement, but the technology doesn't develop in vacuum of requirement. So when it comes to scientific expeditions, that is where you actually create a need. When President Kennedy announced in US that 1961, I think, that they will go to moon, he created a need, and that need created a huge ecosystem of industries supporting this activity. So I think Finally, we are going to ask, if I can launch a 3-ton communication satellite using existing technology, why should I go for a bigger rocket or a more efficient rocket, right? That's the question industry will ask. But a space agency, government-funded space agency, has a bigger task at hand. So I'm sure when you come to the heart of the problem, you have to decide where your heart is. And if you say, I want to go to Mars, I want to go to Venus, you create a need for technology to grow. So I think that is where academia plays a very important role. So again, I would like to reiterate what Sir Aguiletti also pointed out, that there are 3 legs to this stool: government space agency, private industry, and academia. Unfortunately, in India, the strongest of our muscle is ISRO. Academia in space technology and science is very weak. And unfortunately, the industrial base is also very limited today. I hope with the growing need, it can come from academia actually. If we aspire for more and more complex missions, definitely such need will come. So that's why it is, I think, it is a very big responsibility on institutions like IITs and IISTs and so on to propose bigger and bigger missions. Unfortunately, none of the premier institutions of our country ever projected a wholehearted space mission till date. There have been student satellite programs which are sort of half-hearted efforts, I should say at best, because I was part of one in IIT Madras. I think a full-fledged academic push for a space mission, I do not see today in Indian scenario anything other than what IIST is doing. And I think we have a great responsibility on our head. I hope that initiates a lot of questions. Thanks.
Yeah, we'll follow. We'll have a dedicated question and answer session at the end. But that's a very interesting analogy and maybe something to think about for the IIST Alumni Association. If there's something we could do to kickstart and put efforts in this direction. So, well, I'll change the next topic. So, following up on what Amal said previously, right? So you talked about how the continuity and knowledge transfer is very important, and it's also very tricky. So how did you manage it? How do you manage it? What challenges do you face? And yeah, maybe your views on that.
Before I get into that from an institution perspective in Singapore, or where previously I was working at University of Colorado, where I still continue to work there. Let me give an example of the Inspire program, because I've been working quite a bit with IIST since 2015, when I visited IIST and we discussed what can we do together. So I agree with Umesh and Professor Aguiletti, and my background, as you said, Rajna, is I'm an aerospace engineer with an atmospheric science background. So I did my mechanical engineering from College of Engineering Trivandrum. So I have a reason to come to Trivandrum and visit IIST. But when I came here to the US to do my master's and PhD in aerospace, and at that time I couldn't work on the engineering aspect, so I very cleverly started working on the science from the instrumentation perspective. And I worked on a couple of NASA missions doing UV instrumentation. And when we were I was one of the first students on the first NSF-funded CubeSats. At that time, NASA did not want to fund CubeSats. So it was called the Colorado Student Space Weather Experiment, and it flew, radiation belt electron detectors, and it was a phenomenally successful science mission, right? So at that time itself, we had a student who was a PhD student working as a program manager. And we had a systems engineer also who was a PhD student. And these were the students that provided the continuity on the program. So they were there all the way from the start of the funding of the program till the launch. And then we had a lot of undergraduate students who came in and left the program. And that's one of the main problems that you face in academia. IIST has been building an IIST SAT for a while. and I think a few batches have graduated, right? And so how do you retain the knowledge? When your program manager and systems engineer and your subsystem leads leave, how do you retain that knowledge? How do you train the next cohort of students who are coming along? And this has always been a problem. Inspire One got funded in 2017, and I've had IIST interns come to University of Colorado since then. I think I've probably had about 12 students. We wanted to finish end of last year and deliver in January. That we missed that by 4 months. And then now with the pandemic, the satellite's now sitting on the shelf and we can't deliver it. We've finished testing on it. It's ready to be launched, but we can't. So I really wanted to deliver that before this batch of students, graduated, but now they have. So what I have found works is mixing students with full-time engineers works in our lab at least. So we have full-time engineers who are there for supervision, but who is also very involved with the fundamental aspects of the design. And the second, of course, is documentation. We have a standard template for documentation. For Inspire One, I think the documentation has been difficult because we had 3 partner universities. We have National Central University in Taiwan that's building a ionospheric plasma instrument that's flying on it. We have the University of Colorado building a X-ray spectrometer that's looking at the sun in soft X-rays, and then we have IIST students building the EPS and the CNDH of the satellite. So it's a documentation across universities, and managing the program has been a problem. But now everybody's familiar with using Slack and Zoom. We've been using that since 2017, so I think we were a little bit ahead of the curve on that. Our Slack group has been funny at times, irritating at times, but it's been an effective tool of configuration management and sharing documents. But I think that's one of the main ways to make sure that you have continuity. So end of every semester is a review. The first year, end of the semester, end of the summer program, we had PDR. Second year, end of the summer program, we had CDR. And at these times, all the documents get frozen at the state of the work that we are in. The third year, we had environmental testing of the satellite. So that's so that's one way to do it. So again, 2 points, right? One, have full-time engineers be there for continuity and providing guidance and documentation. And the second is, of course, documentation. I will also add that it helps to have a PhD student whose PhD thesis is invested in the science returned from the satellite. I've always made it a point that the satellites we build are not tech demonstrators, because if you build a tech demonstrator, okay, you fly it, and then what's next, right? It's not a sustainable way to go about doing it. So we always have a science focus. We fly 1 or 2 science instruments, and then the PhD students or the systems engineer who's, you do engineering, but then your research and your PhD, you can't write a PhD thesis on building a satellite. You have to do science with it. So that's another way of maintaining the continuity on these student programs.
Very clever point to get to have people high stakes in the project.
Yeah,
okay, that's very clever. Yeah, well, PhD is it's quite a big stake. So Umesh, I'd also like to invite your perspective on this, because as I remember, the physics club, you're the one who started the physics club at IIST, and it was one of the longest living clubs. And also it had the most passionate and involved student members. So what do you think of, engaging students, and also because it's very difficult to engage students and ensure that they participate on a continuous basis, given all the project work, all the assignments, and all the workload that they have. And perhaps you can also throw some light on how you do knowledge transfer and your perspective on all this.
Yeah, actually, I have had opportunities to have discussions with Amal also on this same problem, which I think any academics interface will face wherever you have to do a continuous development and knowledge transfer. The way we work here is almost exactly like what Amal pointed out, but with a slight difference. We do not have permanent engineers hired for this activity. So what we do is we faculty act as the host of the knowledge. We follow a policy where we give some sort of a broad free ground for students to play, and our experience has been that once you give such open ground, the students do far better than your expectations. But of course, the whole activity has to be coordinated. So whenever we do that, we have a team of about a dozen faculty members in different aspects of space science and technology, actively interacting with these students and project staff. We have temporary project staffs, they come, they go. And we act as the repository of knowledge, and we coordinate it. Well, our system is small, we can afford to do it. I know in a bigger system this won't work, but this leaves a lot of space for students to perform. Typically, the way we run the project is we don't assign tasks on day one. We just get a gang of uncontrollable kids into the lab and just tell them, look, we have to finally do this. And again, I know this is, I don't know how many times I have quoted this, but I really love to quote this, is our ARIS example. We had this task and we had very limited time, and I literally pushed practically anybody, like my PhD students, my students who were working on electric propulsion, my student working on the cold atoms, my BTech project students, MTech projects, everybody was working for that duration for about 2 months. They were like, nobody questioned what is my task, what I should do. The interesting part was they managed the task by themselves. I don't know if Sudarshan is around, he will tell you. Sudarshan Karthik, he is from our avionics department faculty, or Anup, they will tell you. I mean, people didn't ask whether this is my task and what am I supposed to deliver. People just, as the situation came, electrical engineers became mechanical engineers became physics students. Of course, you can say this is a very bad way of managing the project, but I think a big project, yes. Let me be very clear. If it has to be, it had to be a 10 or 100 kilogram satellite with many subsystems. Yes, there has to be a task division. But I think students learn much better and acquire more wider, knowledge base when we really leave them to interact with each other and grow. I think Sudarshan is there. Maybe I would really like his comments on this.
Thank you, Dr. Umesh. Like you rightly pointed out, it was just on full throttle, the whole ARIS experience, and the students contributed beyond their, beyond our expectations and beyond their, expertise also. So there was a lot of learning, and they never questioned if it was the task assigned to them or it is an extra work they do. They just wanted to learn, and they were happy to do that. So one thing is scalability, which you rightly pointed out, that for a bigger project, you need this task division. But even in that scenario, the project lead can give ample amount of space for the students to grow and then to explore. Thank you.
Yeah, thanks. Thank you, Sudarshan.
Yeah, thank you, sir. So yeah, that's very interesting. So okay, great. So let's move on to the next topic. So my next question is for Professor Aguiletti, because well, I have personally worked so when I worked with the Indian Space Agency as well as the German Space Agency, there was a lot of cultural differences between these two. But more or less, the space agencies were quite similar in their functioning. But then when I moved to the European industry, and there was a lot of difference in how they functioned. So not only the cultural aspects, but also when you move to another sector or another domain within a culture, there's a lot of difference in how engineers think, how managers delegate tasks, and in general, how the project management differs. So maybe it would be great if Professor Aguiletti, you could, highlight some differences in project management strategies, because you have worked across different cultures, and I'm sure New Zealand is a very, very different culture from Europe or any other places that you have worked. So how do you think project management differs between not only cultures, but also between industry and academia?
Yes, I think yeah, that is a very interesting question because it goes at the root of how project starts and develop. And for example, I had the opportunity to lead and be heavily involved for really large projects in an academic environment and in an industrial environment. And the two things are quite different, if you want. If you think about the university environment, most often projects start like a research proposal, and you have partners in other universities that get together, every partner contributes something, and so you put together this consortium and you bid for a certain amount of funding, everybody's doing something, but the way in which, let's say, like the proposal and then, let's say, like the contract is structured is very loose. You have someone that leads with, this is the idea that what we are trying to do, we will do, a payload, the other people will do, I don't know, some subsystems of the bus, the other person will do something else. You have maybe, 5, 10 different institutions, that try to work together, but with again, a very loose arrangement where, for example, the interfaces are not really clearly defined. And so in practice, when you come to the real hardware and putting things together and testing and so on, there are significant challenges in bringing all these things together, and people that maybe have different expectations, because especially some of the projects I led, again, European projects, so partners in the UK, in Germany, in France, in Italy, everybody with slightly different expectation of what their part really was and what the interface with the rest was. And when you have to bring everything together, clearly, those things have to be clarified exactly, if you want everything to fit and everything to work together as a system. So in these kind of projects, usually is a bit of, the management in the sort of university-led projects is very tricky because, again, there is different understandings of what people really mean, different sort of quality, if you want, of the work, of what you mean with this particular hardware has been qualified, for example. The word qualified for some people means something, for other people means something completely different. And so is, the control of the interface is always something that, is a significant headache, especially for, let's say, the prime that puts everything together, because often in the university, again, is a consortium of partners. It's not like an industrial prime that controls everything and subcontractors that do what is written in the contract. So it's a bit challenging from this point of view. Vice versa, in industry, usually you have, if you think about the same size of projects in university-based or in industry there will be, much more paperwork, much more, control documents and so on, but everybody knows exactly what they are doing, what they are supposed to deliver. So if you want, the project management is easier because, is mostly by the book. There are rules, people know what they are supposed to do. Most often there are large companies that have done these things before and so on. So there are no, the room for misunderstandings is much smaller than the one that there is in academia. And then you have the problems that are really the tricky one when you have the two groups together. And this is often the case that you have academia and industrial partners working together. And often you have a bit of a divergence because most companies, as we said before, they try to minimize the risk. At the end of the day, they have to make a profit. Otherwise, they have to make people redundant. So they try to deliver what they are supposed to deliver. But, usually they don't want to particularly take on more work than they thought they were going to take. Whereas, universities are a bit more flexible in the amount of work. And if, one of the partner, can't do that much and so on, perhaps a university can take a bit more on their side. Again, it's a much more flexible arrangements. Whereas when you have, companies and universities working together, those interfaces can be tricky to manage. And so again, I think that the secret to get these things to work is really an understanding of everybody on what the final goal is, and the fact that everybody has to contribute and be prepared to do something extra and maybe do something more on one area and a bit less on the other area. But really the contracts have to be managed in a much more dynamic way than a classic let's say like industrial project. You see, I don't know if I explained a bit properly what I meant, but
yeah, Very interesting points, yes. Especially, I've also personally observed there's very different definitions of what, let's say, qualified or what's space ready or what's an engineering model, let's say, is. So.
Yes, exactly. And as you can imagine, there can be also, some sort of misunderstandings with the level of documentations, because when finally the satellite is put together, all the bits have to work together. And so, when something doesn't work, usually there is like a chain reaction, someone else is involved. And so there is a problem, try to find, where the problem is. And you have, maybe certain parts that have been, delivered, but it's not really clear how they are working or the testing that has been done and so on. So all this is, again, is, let's say, very, very interesting moments that are in these projects when all the bits come together. But again, I think it's the fun of doing these projects and again, what can be achieved.
Yeah, Professor Aguiletti, if I can comment.
Yeah. Yes, sir. Yes.
Yeah. It's really great to hear that view, because I work with the Indian Space Organization also, and what I found is that in even in bigger projects, the people who sit at the interface of the two systems play a very, very, very critical role in not only in troubleshooting but also saving time. They have to really understand both sides. I don't know if Pranav is there today in our discussion. One of our students, he's an aerospace engineer, and I work with him. Rather, I work under him. He works with RF electronics and superconducting magnets. He's from aerospace engineering, and for one of the work he studied hyperfine spectroscopy. I think he understands hyperfine spectroscopy as good as any of our physics faculty now. So yeah, these kind of people are very, very valuable, very important.
Yeah, I think the role of the system engineers sometimes is not, stressed enough how important that is to get all the bits working together. And often, people look at their own, subsystem and so on, and you have, experts try to again talk to each other, and without someone that actually can coordinate and work at the interface is really tricky. So for me, at the base of every successful project, there is some great system engineer that brought the whole thing together. Rather than okay, clearly you need also the various experts in the various disciplines, but the person that actually joined the bits is really key.
There is somebody who put it all together at the end and made it work. That happens in academia all the time too. Because you're working with students, and then you have less resources. You have quite a bit of times where there is miscommunication, like you said. When something is done, people have different definitions of what is done. What does done mean? So yeah, it makes for a fun environment.
Yeah. And the issue that you mentioned before of the people also coming and going in universities, that also in my institutions we solved in the same way, having some engineer support people that work with students, with the academics, to help, because every year you have new students coming in. The students that go, where have they left that particular piece of hardware? Where did they write that particular piece of documentation? And so also there, trying to make them to write down properly what they have done, where the equipment is, and so on, is always quite a challenge. So it's good if there are actually people that are there, let's say, like all the time, so they can help whenever there are breakdowns of communications between one generation of students and the next generation of students. These people can join the dots, and again, if you manage to do it with the academics and so on, good. But often academics are pulled in a lot of different directions, so we find it is useful to have someone in between that can help with good engineering background, also because they can help students with little things that an experienced engineer can tell them straight away how to do it, and it saves time to everybody, rather than sometimes a student try to reinvent the wheel on something that is for a seasoned engineer would be pretty simple to do, because he knows the secrets of those particular things.
Well, I think space is really hard, and I guess that's so fun. So so my next question, I'd like to have all your perspectives. So this question is for all of you, because at different points during this discussion, everyone has touched upon the similar thing. So which is, how do you think So we all agree that a good relationship, a symbiosis kind of a relationship between space agencies, industry, and the academia is very important. But how do you think that effective long-term ties can be created between these three? So Amal, would you like to start answering? Yeah.
Sure. How do you have a sustainable relationship between the space agency and academia, right?
Yeah, so how do you start? Firstly, how do you approach them? How do you begin the ties, and how do you maintain them? Yes.
Right. I mean, if you look at the evolution of how space science, or I mean, academia gives you the opportunity for research. Academia also gives you the opportunity to take risk and fail, and that should be acceptable for academia. To take risk, new R&D projects, and sometimes fail. That's how you learn things. That may not be acceptable for industry. That may not be acceptable for government missions. Having said that, you obviously don't want to fail. But so if you're going to use academia for R&D, there's two tracks you can take. You can use it for tech development, and you can use it for space sciences. So for tech development, you work on improving your satellite capability and technology, which was a direction that we were taking in Singapore. And recently, the government has tasked us to develop a climate monitoring weather systems approach. So right now, we are trying to develop a weather aspect to the satellite research that is happening there. So what we have found out that, if we are going to be building missions for the defense agency to test an FPGA on orbit, or some piece of electronics that they want to put on their next synthetic aperture radar that they want to test on a CubeSat, that's not really a sustainable model for the satellite center in Singapore. Right, so we would be building these satellites. We would be at the whims and fancies of the defense agencies to give us these projects. If they start giving it to industry, and we have to compete for grants to keep our center. So we need a sustainable approach. We need to have our own research track, and we need to be contributing research products that either research products and writing original research papers in journals, or contributing weather products that can help with the weather forecasting and things. So that's a track that we've been taking in Singapore with respect to developing an application space perspective from the satellites that we are building. In the US, for example, you have academia that builds most of the instrumentation for NASA that flies on almost all of the NASA missions. So if you take the University of Colorado, the lab has been one of the front runners in developing UV instrumentation and solar radiance measurements. And these are used in the GO satellite. These are used in all of NOAA space weather forecasting satellites. So again, there's been a niche that has been created by academia in developing the space science instrumentation. I think in India, ISRO does everything, right? While space science has not really been, it has not grown to the level where academia, by its own right, is fully functional and developing these instruments that can fly on ISRO missions. ISRO has been developing the bus, the instruments, and everything. So I would say that as a space agency and a space nation evolves and capabilities evolve, you kind of find this delineation where the agency becomes more like a program manager. The agency puts together the vision document and the strategic document for what are our goals going to be for the next 10 years. Right, and then you have industry people. You might have in the US, for example, you have Boeing, Lockheed Martin, SpaceX, all building launch vehicles. So you have an industrial base that is building that. Probably ISRO will get there and be branching out the PSLV to industry and all these things that might happen. But then you have academia, or you have research institutes that are building a lot of your instrumentation for these discovery type missions or even Earth observing missions. So you see that evolution. And in Singapore, I would say that we've gone past, okay, we've put satellites in orbit. We have 10 satellites now. What's next? So now in Singapore, I can see that thought process happening where the defense agency is now funding NUS. They've created a lab, space lab in National University of Singapore that's almost exclusively doing defense projects, while NTU and Satellite Research Center is now focusing on the weather and the research side and the space instrumentation side. So that evolution is happening over there. And I see that happening you see that happening in Japan, where University of Tokyo, QTech, all these universities do that, and the same in Europe as well.
perhaps would you also like to add to this? Also, another aspect maybe you would like to highlight is because you've spent quite a lot of time at TIFR. So perhaps you could also highlight on how not only academia, but also research institutions can create ties with space agencies.
Was that question for me, Rachna?
Yeah, Umesh. No, Amal, sorry. Umesh, this question is for you.
Okay.
Yeah. Sorry, did I say Amal? Okay, I'm sorry.
Yeah, that's why I got confused. Yeah, actually, you mentioned about TIFR. That helps me answer the query, actually. Yeah, there are some really crazy professors in some of these institutions. They can come up with fantastic ideas. I would just like to give one example again of Apollo mission. The first contract was awarded within 3 months of the announcement, and that contract was not given to a company, it was given to a professor in computer science department. And that was the first autonomous inertial navigation system contract, which was used finally for the Apollo mission. So the ideas, the radical ideas have to come from academia. The problem is that when you go to a modern institution today, they do not appreciate a component level innovation, but they appreciate a satellite going in space. For example, they would prefer to build a full car rather than building the one valve which actually controls the fuel injection into the engine. So because of this fascination for a full system building, a lot of complications come with academia. So as Amal also pointed out, very nice example that the instrumentation, the payloads, is where academia can actually contribute a lot, because they can not only father the child, they can actually take care of the child till it grows. Today, what is happening in ISRO? ISRO decides the mission, ISRO plans the mission, ISRO builds the payload, ISRO launches the payload, and the data remains with ISRO. Largely, that is what is happening. I'm sure ISRO as an organization also has a cognizance of this fact, but unfortunately, our academia has never shown that level of interest. Not that there is a lack of capability, there's a fantastic capability in our institutions, but there was never a motivation to contribute at the component level. The motivation always has been to contribute on a big project level, and that I think has to change. Once that is done, imagine, I mean, I send a gigapixel camera to Mars, maybe just for the fancy of it, but using an advanced phased array communication antenna, I may be able to beam that information back to Earth and use it. But for that, you require a professor in communication engineering to come forward and say, I will build that antenna for you. That is not happening. So I believe such programs like what we are organizing now, we have to encompass such possibilities and throw these challenges to academia, and I'm sure they will stand for it. But yeah, I mean, this fascination for a complete system building has to reduce a little bit. And I think that is one thing I really appreciate in US universities. They really take it up. They don't only take up only the instrument, they also take care of the data which comes out of that instrument. We need that kind of base. We are trying to create one in IIST, but that's by no scale adequate, or not even beginning of the whole journey. This has to radically change. We have more than 200 universities in the country. I'm sure we can do a lot if individual departments decide that I will look at the remote sensing data, I will look at the mass spectroscopy data from Mars, I will look at mass spectroscopy data from Venus, I will do radio occultation data analysis, and so on. That's unfortunately not happening at the scale it is required. So I think that is where role of academia is very, very critical to interact with in the space agencies and tell them, okay, you build the muscle, you build the brain, I will give you the heart, don't worry. That is not yet happening.
Right, Umesh, I think at the crux of the argument is that the agency has to be able to let things go. They have to be able to say, look, we are going to have, they can do the program management, but they have to say, okay, we're going to have a Mars mission. We are going to have announcement of opportunities for these kind of types of imaging and let academia innovate and build them?
I think the fault lies at both sides, because I had a good fortune of interacting from both sides. I know the apprehensions Indian Space Agency has from the academia, from their past experiences. And I have seen academia very closely asking the exact same question as what you're asking, that, oh, we gave the proposal, but the Space Agency doesn't like it. So this has to grow organically. It cannot be enforced. So a more networking, more experts like you, Professor Aguiletti, and similar experts, when they interact with our academia, encourage, it will be possible. It is not, unfortunately, we are not challenged enough. This I keep saying again and again. We are not challenged enough. When we will be challenged, we will be ready to fight. But I think the fault lies on both sides, at least in India, I can say for sure. And that requires some constructive push from both sides.
Professor Aguiletti, actually, I'd like to hear your views about this, because you were in the UK ecosystem, and we have a very excellent example of SSTL, which was actually a project at the University of Surrey, and it spun off.
Yeah, exactly. Well, exactly. But I would say my experience of, let's start with the interaction between academia and industry, because as I started, I didn't start directly to engage, with the space agency, because, for example, in the UK, typically the space agency, their main aim is the growth of the space sector, but mainly from a business point of view. So they tend not really to engage too much with sort of universities directly, because they think, okay, universities have got their own, chains, the ministry and so on. The space agency is more about industrial growth and so on. So my beginning, let's say, have been really working together with the company, the university and the company. Leave aside the agency for a moment, and working together, spending a lot of time actually in the company. At the beginning of my career, I spent 2 days a week in the company, 3 days in the university. And in that way, you build a bridge between the company and the university. So you get this relation of trust between the two organizations. And then together was much easier to interface with the space agency, because they saw that the partnership was actually beneficial for their final objective of economic growth and so on, because the university working in partnership with the company could actually help the company to grow and then hire more people, pay more taxes, and do all those kind of things that the government really care and the agency had to deliver, rather than, let's fund, university research and so on. The agency will say, well, we are not really into that kind of thing, research. You should try to get the research funded by, the sponsoring bodies that sponsor, research in universities. And you should try to look at from that point of view, rather than, come to the agency. So for me, it was, again, as an engineer, I quite liked, to work on applied stuff, industrial stuff, because I say I want to solve, real problems. Blue sky research in universities is great, and of course is very important, but I always been, a very applied guy. I like to do, applied research to try to solve things. So for me, has been always good to work together with companies, and together then to talk to the agency, so that the agency can see that the whole thing works properly if we all, work together. So that's the way, I approached this whole thing. And going about what the roles of the universities should really be and so on, I fully agree that sometimes there is no point in all of us building, a satellite. It would be like if every person is trying to build a car. And, it's better if, a person can contribute for their area of expertise. And so I think that very often, for example, my particular interactions with the companies have been to support some particular niche technologies that for them were very important, not just, a whole mission, but just different areas. It could be something on the propulsion. It could be something on the structural dynamics. It could be the kind of example that was done before, just looking at the valve, just looking at a particular thing that for a company was very important. And when an academic with this, team of students and so on, you can make a contribution to solve a particular problem. And this particular problem can be in a subsystem that is part of the bus of the satellite, can be part of the payload. It doesn't matter, but it's a particular technology that is useful for the system, because at the end of the day, when the satellite is there and working, of course, the payload is very important, but if the bus doesn't work, then nothing is going to work. So all the parts are equally important, let's say, to deliver a successful mission. And so I see that the contributions of the universities can be on bits and pieces scattered, throughout, let's say, the project. Indeed, if universities have to have leadership of something, it makes more sense to have a leadership of an instrument, a leadership of a payload, rather than the leadership of really the bus. That seems more like an industrial thing where, of course, it is necessary to improve the state of the art, to do R&D and so on. It's necessary also on the bus side. Not just, you can't just, improve and have instruments, cutting edge stuff when the rest of the bus is done with technologies of 30 years ago, because nobody wants to take risks there. So it's necessary also to push the technologies of the bus forward. But again, it is not necessary that everybody has got its own mission. We can contribute our bits to a single mission where every entity contribute their particular thing, with also a space for the students, because in a lot of cases, actually, what we try to do with missions was not just the technology demonstrations of new technology, but was also an educational mission at the same time. So the secret to me is, to bring together different things to justify one mission. It's difficult that you can justify one mission on the basis of one application and one instrument. So you have to bring more things together. And so for us, one of the components that we also tried to bring in was the educational aspects. So the project had, the demonstration of some technologies that were important because a company wanted to see if that technology was really working in space. At the same time was educating a group of students. So that was another thing. And pushing forward some particular, scientific objective. If you manage to get these three things working together, then essentially you can really justify the kind of costs and so on that are involved in putting together a space mission.
Interesting pointers. So we actually have some questions in the audience actually. So maybe before we proceed on to our next discussion, we can shortly take some questions. So one question I see is, so someone wants to know, because for an academician, someone in an academic setting, the primary interest is teaching and research, of course. So how do you align your research with a space mission, for example, one that requires a lot of system engineering work? So how do you align your research with a space mission that, I'm getting a resound. Yeah. How do you align your research with a space mission that requires a lot of system engineering? So would anyone like to answer this question?
Yeah, I mean, you don't have to align your research. You just have to apply your research. And I'm sure, as long as you're working in the field of science or technology, no matter what, I'm sure the expertise of a professor, I'm not talking about a student. The student may be working on, say, somebody is working on a titanium support structure for bones, for example. He may not have a direct application to space, but the professor who is guiding him would have excellent knowledge of titanium structures. So he can definitely apply that. Again, the problem, at least in Indian context, I can tell you, the problem again comes is that when we look at, even as professors, when we look at the space technology, we look at it as a system. We never bother about the component. If we bother about the component, whether it is actual structural component, analysis component, or application component, once we reach to that stage, I'm sure anything what we do has some connection to the space science and technology. So if there is a will, I'm sure there is a way. There is no need to align yourself. You just have to say, okay, I have 5 students working on, say, I do atomic and molecular physics. I have 5 students working on atomic and molecular physics. I will have one of them working on atomic and molecular physics of moon. That's all. Maybe I'll have to read slightly different type of papers, but it's the same thing.
Okay, that's good to know.
I can say, if I say, for me, there wasn't really ever a big problem of alignment, because the alignment came naturally from the partnership, and I'm talking, if you have a good partnership with a company with non-disclosure agreements and everything, you discuss what's going on, what the challenges are. So you are naturally aligned because you want to find out the answers to the same questions. You want to understand why certain things are not working as it should, or how could you do something that does a particular job, and at the moment we haven't got anything that does that particular job. So maybe I was lucky enough that because of a very close partnership, you tend to be technically aligned on what you want to do, because you want to solve the same problem, and then you distribute the work between what is the part that the university can do and what is the part that the company can do. But the objective was always, again, we discuss it together. What was the challenges? What is that we would like to do in 5 years' time, in 3 years' time? What is that is missing? And so I was, relatively lucky that I never felt that I had to, move myself and my research to meet, something else. Because again, the questions that we had were the same, because were the result of, discussions that we were having together. We were going at the same conferences, sharing, the same kind of knowledge and the same kind of interest at the end of the day.
So, Ratna, if I may add to that, I think the question had two aspects. One, how do you align your research with the missions you're doing, and does it take away from doing some of the systems engineering work that as principal investigator on a project you're supposed to do? I think that is a very valid question. I've been struggling with it. Right now, I'm principal investigator on 4 satellite missions, one of which has no relation to the research that I do. But at least on the other 3, there are instruments that look at data, that produce data that will be useful in the type of research that I do. So I actually try and write proposals on that. But sometimes, you have to write proposals that the funding agency wants to do, and you do that. But the other aspect of that is something that's always a learning experience for me, because as a professor, you're always pulled in so many different directions. Professors, at least in NTU, are glorified program managers. You're running an institute, you're having this chunk of funding for building all these satellites, and then you're managing your staff, your students, and trying to get that done. And then you have your time commitments with all of these, which means that sometimes you're not able to spend as much time on systems engineering or providing the guidance that sometimes students need. And it sometimes, if you have students who are really motivated, and most of the students who come and work on these projects I found are really motivated, it works like Umesh said. You tell them the problem and they hash it out, and you give them a lot of rope. Sometimes they hang themselves, but you hope that they get the job done in the end. But yeah, it would be nice to spend a lot more time. I've had a lot of students from IIST, and sometimes they've been in Colorado and been on their own, and I do wish that you do have some more time to spend on it. But as professors, you have all these different commitments and different projects, and you try the best you can. Of course, you try to do more systems engineering if you can, but it does take it away from that.
Okay. Yeah, Regina, can I add to that?
Yes, sir, of course. And hello to you. Nice to see you after a long time.
Yeah, nice to see you. Yeah, so what Amal was saying, the issue in India, even in engineering departments here, is that most of the faculty don't see much value to system engineering kind of work. What they see value to is actually what they regard as more basic or applied research. So unless there is some value put to that in terms of recognition at some level, in some form, it will be very difficult for faculty to get into that. But somebody like Umesh, I see him working in all fronts, both applied research, basic research, as well as a lot of system development and system work. And that is his passion. He has a passion for that. But most faculty see it in a different way. So I think in some way, some value has to come into system engineering kind of work for more faculty to start working like that.
Yeah, thank you, sir. That's very diverse and very interesting perspectives from all of you. There's another interesting question, actually, which I'm sure a lot of students always face. especially those who want to get into subsystem design of space systems. So the question is, let's say there's a student who wants to get into satellite building or space missions in general. Do you recommend that they pick a subsystem in their, let's say, at the university, at the undergraduate or the master level and stick to it? Or do you think they should experiment with different subsystems? So what's your advice? Yeah, all of you.
The choice should be made in the beginning and should be given a fair shot. I should not keep changing my goal every day morning. So when you choose judiciously with the help of your professors, and then just stick to it for sufficiently long time. The advantage of being in academia is that failure is an option. So
yeah, stick to it for a while and try to see a project through. But it's okay to want to do different things. And one of the reasons why I build CubeSats is that I can dip my fingers into everything. But if you're working on a very large satellite project, you are usually, you just work, and people in ISRO who are IIST alumni working in ISRO will now know, right? It's very, you work on your subsystem or your specific task. But with CubeSats, that's one of the, because we are so lean, the teams are lean and the funding is also very lean, we have to wear multiple hats. So, one day you'll be doing electrical system testing and the next day you'll be trying to debug an FPGA code. So, you get the full.
Yeah, I guess that it is the usual tension again between depth of knowledge in a very narrow area of a broader knowledge on a lot of different things and more towards, let's say, like the system engineering. It's not that there is a right and wrong. It's only trying to balance this one. Of course, the universities would like us to be these T-shaped individuals, so very deep in the knowledge of our subject, and at the same time have also very wide, knowledge on all the various different things. But I think it's good to appreciate the depth that there is in every subsystems. So for a little bit of time, to get that kind of thing rather than immediately do a lot of different things and all of them very superficially. I think at the beginning to a good understanding of the level of complexity that there is, because often, sometimes people really underestimate the kind of issues that there are with every simple system, even I don't know, in the sizing, the torque that you have to apply to a particular bolt. It seems a very simple thing, and then you discover that there are people that spend their whole research life to work out exactly the relation between the torque and the preload and the thread of the bolts. So that's the kind of, so a little bit of time initially spent in appreciation the depth that there is in every subject is good, because later on, when you will deal with all the people, if you are like a system engineer, you will be dealing with people with a lot of different backgrounds and so on, you will have an understanding, that you will at least have the understanding that behind what they say, usually there is a lot of knowledge, and one shouldn't really underestimate that. What the expertise really bring in. So, sometimes the problem is that we have is that, seen from a non-expert, a lot of things seem very simple. Well, it's very simple here. It's not very simple. And in everything, there is really a depth of knowledge. So a little bit of time at the beginning spent going down in the depth of knowledge in a particular area is a good thing also for the future career. Even if the future then of this particular person is more into the system engineering, it will be, a kind of a good experience, the one spent in going in depth for a little bit of time.
Oh, I also agree with all of you. So I also like to add to whichever student asked that question, because as I noticed, as an engineer working with an SME, I've seen software developers building harnesses, and I've seen project managers also preparing equipment for testing, and so I've seen them cleaning flight model boards. And so you basically get to do everything. You have to do everything, and you should especially if you're, let's say, a mechanical engineer or a purely software person, it's very, very important to know where to put a resistor and where not to put a resistor, or where a capacitor goes, because you don't want to screw up everything. So yeah, it really helps. The more diverse, the more wide knowledge they have, the more it helps. Not only in working, but also in communicating, right? So because if, let's say, you're just writing code for a system, for an onboard computer, it's not that you don't talk to anybody else. You talk to the electrical engineers, you talk to the mechanical guy. So you should speak the same language. But I guess we have some more interesting questions. Wow, that's a lot of questions. There's one. Okay, maybe we can skip the super technical ones. But does anyone want to ask the question on the chat by themselves? Anybody wants to interact with somebody, or? Okay, then I will just read the questions from the chat. So we have a really SpaceX enthusiast who's asking about the Raptor engine, but I guess this is not, I don't think any of the panelists have a chemical propulsion background. So unless Professor Aguiletti would like to, okay. Okay, maybe I would, whoever asked this question, I'd strongly recommend you to go to there's a really amazing SpaceX page on Reddit, so please go through that.
But the question is slightly different in nature. The wordings may be right, the meaning may not have reflected there, but assume that technology development has stopped at a particular design is not really correct. There is always a scope of development. So no, SpaceX has not saturated the design of liquid propulsion yet. I doubt if that will happen in near future. We have expert aerospace engineers here. There is much more scope than what SpaceX has been doing. So yes, there is a lot to do in chemical propulsion. That was the question, actually.
Okay.
That's how I understood the question.
Thanks so much for clearing that up. So there's another interesting question. So someone asks, does failure impact your career in the academia? Because it's a common theme that all of us agreed that failure is extremely integral to success. So you should fail many times, highly recommended. But has failure affected your career paths personally or professionally?
Will affect it. If you're funded by a space agency to build a satellite and it fails, they're going to think twice before giving you a grant again. Because in academia, your reputation is based on the projects that you do. But it's part of the game. I've been in a project called Glory, where the satellite didn't fail, the launch vehicle failed, and it ended up in the bottom of the ocean. So, but especially if a satellite fails, it's also a very difficult thing to take, because you spend quite a bit of your life in building the satellite. It's usually a 3.5 year process, and you build quite a bit of invested quite a bit of your life in it. So personally and professionally, failure does affect you, but there are always lessons to be learned, which is why a fault-free analysis is very important. And there are lessons to be learned and why it happened, and sometimes it teaches you more. So yeah, it's part of the nature of the industry that we are in.
Okay. Professor Aguiletti, you have mentioned that the system level, let's say a satellite bus, that expertise should mostly be left to the industry, but then a domain expertise has to be built up by academia, right? So, like for example, an RF expertise, or an academia, a university should try to excel at one particular area. But then how do you think this happens? Because this is an incremental process, and then it takes many, many years to build this expertise. How do you think universities should go about?
Yeah, in fact, to me is, academics most often have a particular area of expertise where they can make a significant contribution to some of the subsystems that there are on board the satellites. It could be, I don't know, the telecommunication. It could be, I don't know, the reaction wheels, any of the subsystems. So to me, that was what I saw, a lot of the contributions to the improvements that can be made on the bus side of things, okay, on all the subsystems that then will support the payload, can be made by academics that are experts in the various areas that are necessary. I don't know, the thermal control, or that is how I see it, rather than academia being sort of responsible of the system engineering of a bus, okay? Because when you are talking about, a significant satellite, there is a lot of that sort of like, project management that has to be done, all the management of the interfaces, all that kind of thing, that often is not really the kind of thing where academia is best, let's put it this way. So in my opinion, the way where academia can really make a good contribution to improving the bus is contributing to the various subsystems that are part of the bus. Exactly like in a car, there might be people that makes a contribution on the acoustics that there is inside, the vehicle. There are other people that might work on the vibration and on the comfort. There will be experts that contribute on the combustion, on the chemistry of the fuel, for example, on the suspension systems, on the shock absorbers, whatever you have. There are many niches area where academics that are really specialists in that particular area can make a significant contributions, and so you have all these contributions to all the various little parts, and eventually the car becomes a better car. But you don't have an academic that suddenly designs a better car. You will have some academics that work on the aerodynamics, some other academics that work on the rubber of the seals, and so on. And overall, you put all these things together and you have a better car. But the better car often will be produced by a company. And I don't want to mention companies that build cars here, but you see what I'm saying? However, all the various bits that are in the car, they continuously improve, and that is the bits where the academics can make significant contributions.
Okay. Okay, that's interesting. So one more question. This is from the Facebook live stream. So we have all discussed a lot of pain points for the academia in engaging with space industry and the agency, and what the agency can do to engage the academia more, and so on and so forth. But is there a forum, or is there some common platform or some sort of a discussion where these concerns are communicated to the space agency or the space industry by the academia? So is there something like this in Singapore, or maybe New Zealand, India? Well, as far as I know, I don't think so, but maybe Umesh can shed some light on this. Well, this question is for all of you, so feel free to take your turns.
I'll go first. Yeah, in Singapore, we have regular meetings with the funding agencies where they communicate their needs to us, so like you said, Singapore doesn't have a space agency. So what it does have is something called that is under the Economic Development Board that promotes space technology, which has a very strong applications focus. So they communicate to us when they have the next 5-year plan. They communicate to us how much funding would be available and how much of it would go to industry and how much of it would go to academia and what they're looking for from academia. So there is a very streamlined process where the needs of the agencies are communicated to academia, and we communicate our needs in terms of what our research priorities are. So there is a good system, and being a small country, you can do that. In the US, of course, there are town halls that happen. So NASA holds town halls in meetings like the American Geophysical Union or the COSPAR meetings. There are town halls where academia and the agency have a direct communication, and NASA communicates, how much funding is going to be, what the next announcement of opportunities are going to be in terms of Earth observation or exploration. So there is a path there. So these help in terms of the preparing the academia for what's coming, what is going to be available in terms of funding, so we can plan. We can plan for how many engineers we'll be able to keep for the next 4 to 5 years, how many missions we can expect, and so forth.
Yeah, in Indian context, at least what I know of is that ISRO has been often communicating and interacting with the academia. Particularly, I have noticed that when there is a very specific issue, maybe regarding cryogenics, materials or something, they do consult the professors with correct experience. As Professor Aguiletti also pointed out, there are guys who, I mean, he gave a fantastic example. In fact, I give this example every time I am teaching students how to, tighten a bolt on a high vacuum flange, because there it really matters how you put the torque. And I try to explain to them that there are some engineers who have spent years of research finding out how to do this. Okay, so don't do it blindly, just have some cognizance of that. So yes, the space agency, at least in India, has been communicating. I wouldn't say it is very open. There is no common forum, I believe, as far as I know, but there has been communication. People have been consulted. So there are 3 levels academia can engage. Just to add to the point Professor Kurian Isaac also mentioned, not everybody has to do space engineering or space science. They do not have to. So some professors have been helping ISRO in solving a very localized, very focused problem by spending maybe a few hours on thinking about how to solve that problem. For that, ISRO or a space agency has to communicate to those professors that I have this problem, can you solve it? In a very limited sense, that is happening, and that needs to grow because we do have excellent expertise in many engineering areas and science areas. The second level is where a more serious commitment comes. Like for one of our plasma thruster project, we have a couple of experts from different institutions in India. They spend a considerable amount of time designing, discussing the design and design details with us and correct the design. So that is more, but there is no funding exchange. The third level comes when there is actually a responsibility sharing and funding. Now that is what I meant by aligning your research to a space agency. That is where you actually take up the responsibility of executing something. So that everybody doesn't have to do that, but at least some people have to do that. So that is not happening much in India. But the first 2 levels, I believe, to some extent is happening, but I think that can act as a platform on which we can grow. So I'm sure there are a lot of young IISTians, engineers working with various space agencies, not only Indian Space Agency are here. I think this is a very important request to them. Whenever you face some very tricky issue, I'm sure your professors in your alma mater or other institutes will be there to tell you. You have to just approach them. And I personally have interacted with several. Our LPSC friends come with some problem to me. I have no answer for it, but I know the person who can answer. So I contact that person at a personal level and I do get answers from them. And then at some level, they actually get formally associated. And I'm very happy to say that at least 1 dozen examples I can give you from Indian academics. When I approached them with a challenging problem, they liked it, and now they are sort of members of at least a review committee. A few of them have taken responsibilities of a funded project, but a good number has taken responsibilities of helping with their knowledge base. So this is something which definitely is there in India, but it needs to grow. It needs to grow multifold. So if any of you young engineers have an idea of making a forum where your space agency will allow you to state the problem and the academia is allowed to look into that problem and advise you, I think that is a good idea. If you can move this idea and get the right people look at it, that will be excellent.
Okay, Professor Aguiletti, is there any kind of a forum, either in the UK or New Zealand?
Well, yeah, actually, I have seen two completely different realities. For example, coming from Europe, the European Space Agency is really large with a lot of technical capabilities, and so has got, if you want, a kind of a function, a regulatory function, but has got also a very important, technical function. There are people with really technical expertise, so they can, develop things, although mostly they tend to get companies to actually build the hardware, but is a sort of shadow, and really he's hands-on in the development of large missions, satellites, and so on. So indeed they have a lot of technical capabilities, and really a role where they lead, let's say, like the direction of the whole space sector, and they do that engaging with all the politicians, with all the organizations, academia and so on, of all the various countries. So this is, if you want, one side. On the other one, here in New Zealand, an agency that is, really small, was just set up, a few years ago. So it's completely different. And mainly the agency here is, if you want, has got a regulatory function to make sure, the licenses, for example, for the rockets are sorted appropriately. But having got, if you want, that kind of technical capabilities and the desire to really be hands-on in the development of missions, like, for example, is a European Space Agency. Here, mainly, what the agency would like to see is really a growth of the sector. So they are trying to help to establish that kind of ecosystem that is very important to grow the sector. So, for example, here in New Zealand, there is a launcher, Rocket Lab. We have the capability to put satellites in orbit. Clearly, also India has got that kind of capability, well developed and so on. But now we have the challenge to try to help the growth of really a space sector in terms of, the satellites. Because, okay, it's great to have, the capability to put satellites in orbit, but it's even better if you actually have a lot of companies that then they are developing satellites. So between the two, the two go hand in hand, and then they create the kind of synergy that helps, the economic growth and so on. So here in New Zealand, again, the agency is not technically that hands-on and putting money, a lot of money in, we want to develop a mission to go and, I don't know, do this or the other. Although recently they have put a significant, for example, contribution to a mission to monitor methane in the atmosphere. Okay, because clearly that is a very important thing. The government is quite sensitive, and rightly so, to the issue of planet, climate changing, all these kind of things. So they invested some money in that, but is not that kind of engagement with companies like you have in other realities, like, again, European Space Agency. Okay, so I think they're a bit different type of agencies. And here, for example, again, I do not think that the agency is really planning to acquire a lot of technical expertise themselves. They want to engage with industry and academia and help them to go in the directions that they think is best. The agency doesn't think that they know exactly, what technically, they don't want to put money and bet on horses, let's say. If you want, is a bit different from maybe what's happening in Australia, where the agency is intervening more, in the space sector and putting some, significant amount of money to try to develop particular technologies and so on. So they are trying to steer development. Here in New Zealand, if you want, is a bit more, again, trying to facilitate, but then let, if you want, the market and academia to lead the way in what directions they think is sort of best.
Okay, thank you again, Professor. So we will close the discussion, but before that, just one last question from a participant. Nidhi wanted to ask a question on the audio. Nidhi, would you like to go now?
Hi, thanks, Rachna. This is Nidhi. Am I audible?
Yes, Nidhi, you are. Please go on.
Okay, great. First of all, it's such a great pleasure to interact with the panelists. Thank you for the opportunity, IIST alumni. Um, oh, well, I am working as an engineer currently with ISRO's Satellite Center. So my opinion is from the industry side. In my opinion, within Indian academia, a lot of motivation to collaborate with industry is lost while translating the working methodologies during the interaction. So, of course, the reason is we have dissimilar methodologies due to our objectives being different. The industry is more bent on getting the system right, and the academia has the science as the primary motive. So that is understandable, but I also feel that this might be the reason that deters the creation of massive collaborations between industry and academia within the country at least. So I, being at the industry, feel that we may need a system of proper information exchange with a proper format that would enable efficiency in this process. And I was curious to know what is the opinion of the academia regarding this. And if there could be a system, what kind of system can be proposed?
So Nidhi, are you addressing this to any particular or?
No, I'm actually open to hearing from any of the panelists or from the audience, anybody.
Yeah, I mean, main issue here again is that ecosystem. It's as always, necessity is mother of invention. We have to have a ecosystem where there is a proper cost benefit analysis of doing both. I being from say fundamental physics, I will always question why should I go to industry? Or industry can ask the same question back to me. But if we jointly work on, say, we have these pollution under control instruments where they do elemental analysis or molecular analysis. Somewhere, if the industry needs me, industry will come to me. Or if I can think of such an instrument, I will go to industry. The industry base in India has largely been production oriented than product oriented. So there has to be some change in that. We have to get into one of the reason why space industry is so active, small satellite industry is so active, 3D printer industry is so active in India, is because it is not production oriented, but it is product oriented. So I think we have to start with product oriented industries, niche products, as Professor Aguiletti also mentioned, and the industry will look for academicians with that specific narrow expertise. They will go to them, and then the system in the academia also has to appropriately reciprocate by having a proper system. For example, today if from an academic organization in India as a government employee I have to interact with industry, there are a lot of procedures and bureaucratic hurdles. So they have to be simplified. Proper incentive has to be given, and such guidelines perhaps Indian academicians can accommodate or adopt from the more seasoned counterparts all over the world. So that is a slow process, but I'm sure it is going on, particularly in big institutes, well-known institutes. There is a cognizance of this problem and they are actively solving it. So I'm sure you will see more and more industry academia interaction in India. But these are the main issues. Like, first we have to have an industry which is product oriented rather than production oriented, and then they approaching the expertise in the related areas. And the other way also, of course, that the academia also has to think of a product sometimes and then see which industry can actually realize it. So this will grow, but I'm quite positive. We are in a very interesting time, particularly in India. So I'm quite positive about it.
So Nidhi, you mentioned differences in methodologies, right? So are you do you mean the different standards? Do you mean the differences in how academia, for example, might build an instrument or a subsystem, or what ISRO standards might be? Are you referring to that?
No, not exactly that way. What I meant is the way that we approach
Okay.
the process of building a particular product, let's say.
Okay. So yeah, academia might be building it from a more abstract and more fundamental research perspective, while industry and ISRO might be building it from a more practical, near-term perspective. Yes. So I think you have to. It comes to requirements, right? I mean, you have to very clearly define your requirements about what your end objective is supposed to be, and then you can have in academic partners fulfilling that requirement. So as long as that requirement is well defined, I don't think you would have this really massive mismatch in terms of how people approach their problem, as long as the end result is there.
Your question answered, Nidhi?
Yeah, Rajana, can I come in?
Yes, please. Yes, sir. Of course.
Yeah. So, Nidhi, the academia, most faculty are most comfortable if the industry is able to pose a very narrow question to the academia in the particular expertise area. And they will be very proficient in suggesting ways of solving that. But if you pose the problem of developing a product or a system, then there are not many people in the academia who are able to take that up. On the other hand, a new idea proposed for a product, academia would like to develop, but they may not be able to stick to the kind of timelines and quality that is expected typically in if it has to fly to space. So most of the academics in India would be comfortable solving problems which are in the very narrow specialization, as Professor Aguiletti was indicating. So what I see is that there has to be a significantly good liaison between the industry, space agency or industry, and the academia. People who are able to pose to the academia problems in a way which appeals to the academia and which really taps the expertise of the academia. I'm talking about small, narrow problems, because system developments and other things are different things.
Professor Umesh and Amal, thank you so much. I think I can take this feedback back to my colleagues also, and maybe at least from a smaller angle, maybe we can start a change in the industry as well regarding this. I'm curious though how this system works outside India. If Professor Aguiletti would be kind enough to say something about that.
Well, I would say that normally academia is not really great, let's say, like, building and delivering, a product, let's say. Companies are better at that, and they try to deliver something that is reliable at an appropriate cost, because that is how they survive. They are a business. So they have to have a customer that is willing to have a price, that is willing to pay a price for a certain product that does particular things without any surprises. So that is what industry sort of does. In universities, we are doing something a bit different. We do research and we do education, and part of our research is actually to try to show that what we are proposing is not just words, but actually is going to work. And so there is the fact of a technology demonstration of a proof of concept to see that what we are proposing is going to work, and then is going to work hopefully to the point that can become a product in a company that will then routinely build that particular thing based on an idea that was originally developed in academia, and academia proved that it worked. And then again, industry takes it in, and from, let's say, like a prototype that was done in academia, they developed a product Okay, so to me, that's the different thing. When universities want to actually, really build products and so on, then they should, usually they spin off something, they spin off a company, and then that company, builds a product and so on. So that is the kind of how I see the two things.
Okay, great. So I think it's already past, it's already Saturday for Amal now, and it's quite a long session. It was really interesting. Maybe, so I will close now, but maybe closing remarks, would Manish or anybody from the alumni account would like to, yeah. Manish, so over to you.
Yes, thank you, Rashna. As we come to close of the event, we have a lot of people to thank. And before going into it, a lot of us students, while we were at universities, these projects really helped us shape the engineers we go on to become. So we were really interested in learning more about how these projects can be made more sustainable, and that's why we came up with the idea of this session. I would begin by thanking Director IIST for the welcome address and for his continuous support. I would also like to thank panelists and Kurin Essex sir, Sudarshan sir, who joined us for their experiences and insights. Those were really helpful. I would like to thank Rashna for moderating the session so well. And lastly, I would give a shout out to all the event organizers and outreach team for their efforts in bringing this event to life, and participants for their excellent questions at the end. Also, I would just say a thanks to our alumni faculty coordinator, Dr. Shaijamon. With this, I think we can close the session. So thank you everyone for joining.
Thanks a lot.
Yes, great.
Bye, everyone. Have a nice weekend.
Thank you.